at trig functions and the unit circle. So, trig functions, they're just a ratio of the sides. So we're going to pretend theta is our angle here. So this will be the opposite side, adjacent side, hypotenuse. Hypotenuse, always across from the right angle. So, don't know if you learned SOHCAHTOA, but memorize it. So sine is opposite over hypotenuse. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Tangent is opposite over adjacent. I'm going to fill out this bottom part here, this reciprocal functions part first, and then go back and fill in the secant, cosecant, and cotangent. So reciprocal functions. Cosecant is the reciprocal of sine. So cosecant, reciprocal just means you flip the fraction. So hypotenuse over opposite. Secant is 1 over cosine. Oops. If I can spell. So hypotenuse over adjacent. Cotangent is 1 over tangent. So that's adjacent over opposite. So let's look at a few. So here's theta. So I will label all the stuff. So opposite, adjacent, hypotenuse. So sine is opposite over hypotenuse. Cosecant is the reciprocal of that, 13 over 12. Cosine is adjacent over hypotenuse. Secant is the reciprocal of that. Tangent is opposite over adjacent. Cotangent is the reciprocal of that. Okay. What if we don't have a third side? Opposite, adjacent, and hypotenuse. We can use something called Pythagorean theorem. So a squared plus b squared equals c squared, where c is always the hypotenuse, so 29 squared. And then a and b are just the other side lengths. So a squared plus 20 squared equals 29 squared. See, a squared plus 400 is, I don't know what 29 times 29 is. 841. So subtract 400. A squared is 441. And then square root of that. Oops. It's 21. So now sine is 21 out of 29. Cosecant is the reciprocal. Cosine is adjacent over hypotenuse, and that's a 9. Secant is the reciprocal of that. Tangent is opposite over adjacent. Alright, let's do one where we're missing a side and have a radical. So I'm missing the hypotenuse. Opposite, adjacent. So a squared plus b squared equals c squared. I'm going to write over here 6 root 3 times 6 root 3. You can multiply the outside, and then you can multiply the inside. And then we can do 36 times 3, so 108. Or a square root times itself gets rid of the square root, and you have just 3. 108 plus 36 is 144, which makes the hypotenuse 12. So sine opposite over hypotenuse, and the 6 and the 12 can reduce, so it's actually root 3 over 2. Cosine is adjacent over hypotenuse. which reduces to 1/2. Tangent opposite over adjacent. That's supposed to be a 3. 6 and 6 reduce. Just left with root 3. So now when we go to do the reciprocal here, do my side work up here. 2 over root 3. It's not proper to have a root in the bottom, so we can rationalize it by multiplying both top and bottom by that radical. Because on top we'll be left with 2 root 3. On the bottom, root 3 times root 3 cancels out to give just 3. So we have 2 root 3 over 3. This reciprocal is just 2. And then this would be 1 over root 3, but rationalize the denominator, so root 3 over 3. Okay. We can use these to find the rest. So we have some right triangle, we have some theta, and we know the opposite and adjacent. The opposite is 7, adjacent is 24, and we can find the hypotenuse. 7 squared plus 24 squared equals something squared. So 49 plus 576 equals 625, which square root of that is 25. So we can find the rest. So tangent, we already know, is 7 over 24. Cotangent's got to be 24 over 7. Sine, opposite over hypotenuse, and reciprocal. Adjacent over hypotenuse and reciprocal. Okay. All right, special right triangles. These are things that we should memorize at least the rules for. So 30, 60, 90, short leg. The long side is x root 3, and the hypotenuse is 2x. In a 45, 45, it's an isosceles triangle because the base angles are the same, so the side angles have to be the same. And the hypotenuse is x root 2. Now, if you memorize your sine and cosines of 30, 45, and 60, it'll help you fill out the unit circle. So I'll just fill these all out. Well, let's do it. I'll show you the work for it. So sine of 30 is opposite over hypotenuse. Well, the x's just cancel, so it's just 1/2. Cosine of 30, adjacent, so x root 3 over 2x. So the x's just cancel, and you got root 3 over 2. Tangent. That is sine over cosine. So tangent is 1/2 over root 3 over 2. I've always learned that a fraction over a fraction is big C over little c. So big C is 2 times 1, which is just 2. And little c is 2 root 3. Well, the 2's cancel out. I'm left with 1 over root 3, which we don't like. So it's just root 3 over 3. Cosecant is the reciprocal of 1/2, so 2. Secant is the reciprocal of 2 over root 3, but we don't like radicals, so 2 root 3 over 3. Cotangent is 1 over root 3 over 3. So big C over little c, so 1 over 3 root 3, but rationalize the denominator, so you get root 3 over, let me rewrite this out where I have more room. 1 over root 3 over 3. So big C over little c, 3 over root 3. So 3 root 3 over 3, and it's just root 3. All right. 60 is just flip-flop the sine and cosine because we flip-flopped the opposite and adjacent. So root 3 over 2, 1/2. Let's look at root 3, 2 root 3 over 3, 2, and root 3 over 3. Now the 45/45s. Your sine and cosine are going to be the same because they have the same side lengths. So x over x root 2. Well, the x's cancel. We're left with 1 over root 2, but you need to rationalize it. So that's root 2 over 2. Sine over cosine is the same thing, so that's just 1, which means cotangent is going to be just 1. And then your cosecant and secant is the flip of root 2 over 2, but we don't like radicals in the bottom. So that is 2 root 2 over 2, which cancels out and leaves just root 2. Alright. Now, the reason that helps us is because we're going to do the unit circle in a minute, but we got to do this thing called reference angles, because that's going to help us form the unit circle for some angles. So let's draw where 150 is. It's about here. The reference angle is the terminal side with the x-axis. So I want to know what's the angle here. So the straight line here is 180. So if I just take the difference between 180 and 150, so I get 30. That's that reference angle here. 315 is here. So what I want is the x-axis and the terminal side. So I want that angle. So that angle is going to be 360 minus 315 to give me 45. Negative 240 just tells me the direction I'm going. And then I want the reference angle. So it's still going to be x-axis with the terminal side. So I can do 240 minus 180 to get 60. Now we can do it in radians too. 5 pi over 3. It's going to be here. And then we want the reference. So between here and here. So 360. Oh, I'm in radians. So 2 pi minus 5/3 pi. Well, 2 pi, I can rewrite that as 6/3 to be common denominator. 6 minus 5 is 1. So pi, the denominator is 3. Pi over 3. 7 pi over 6 is over here. So I can do pi over 6 minus pi, which I can make that. Oh, that's supposed to be 7 pi over 6. 7 pi over 6. I can make that 6 over 6 to be common denominator. I'm left with pi over 6. Negative just tells you the direction. And we can take 5 pi over 4 and subtract off pi. So I'm going to do 4 pi over 4. So I get pi over 4. Alright. We can use that with trig functions. So instead of sine of 120, we could say, oh, what's the reference angle for that? So think of a coordinate here. 120 is going to put us, let's see, somewhere here. So if I think about making a right triangle with that angle, right? So this outer piece is the 120. So what's the reference here? 60. So sine of 60. Yeah, as we just did on the other side. Root 3 over 2. Right? Let's look at tangent. So 11 pi over 6 is here. My reference angle is gonna be whatever 2 pi minus 11 pi over 6 is. So 2, let's make that 12/6. So pi over 6. And what is that as a degree? Times 180 over pi. So 30. Tangent is sine over cosine. And let's see. Sine would be -1/2. And cosine is -3/2. So then big C over little c, I get -2 over 2√3. So I can cancel out my 2's. And then rationalize the denominator, so I get -√3 over 3. Alright. Quadrantal angles, that just means the terminal side shares the side with the axes, whether it be the x or the y. Alright, start looking at the unit circle. So a unit circle, P is just some point on this circle. Now the unit circle, what makes it special, means it has a radius of 1. Right? When I do opposite over hypotenuse, that ratio gives me the y value of that point. The cosine, so the adjacent part here, gives me the x. So tangent is sine over cosine, so y over x. Cosecant, the reciprocal of sine, reciprocal of cosine, and reciprocal of tangent. We can write the coordinates instead of x, y. We could write that as cosine theta, sine theta. Okay. Unit circle, we usually map the 30, 45, and 60 degree angles and their multiples, so in each quadrant, as well as the 0, 360, the 90, the 180, and the 270. Okay, so let's fill out the unit circle and then come back and use it to get all these values. So we have the degrees and we have the radians. So we've already filled out in our chart earlier what the sine and cosines were for these. So I'm just going to refill them out here. So √3 over 2 and 1/2. Now, in each quadrant, you can find kind of where it matches, because the angle we reference here is 30. So we can look at all the other quadrants and find out where there also is a reference angle of 30. That's not a straight line, but here. So the values are going to be the same, so √3 over 2 and 1/2. But think about what quadrant we're in. X's are negative. Whoops. Y's are positive. So it's a negative √3 over 2 and a positive 1/2. Now, the third quadrant, you're going to have negative x, negative y. So both are going to be negative. And it's going to be this angle here that has that reference of 30. So negative root 3 over 2, negative 1/2. And then the last quadrant is going to be this one that has that reference angle of 30. And this one is positive x, negative y. So root 3 over 2, negative 1/2. The 45s are the easy ones. They're the ones in the middle of every quadrant. And they're the same. It's root 2 over 2. So you just have to know where the values are negative. So negative x. Negative x and negative y. Positive x, negative y. And then the 60 is just the flip-flop of the 30. So 1/2 and root 3 over 2. Negative 1/2, root 3 over 2. Negative 1/2. Oh, I have these shifted. Silly. The middle goes here, root 2 over 2, root 2 over 2. This one should be negative root 3 over 2, 1/2. And this is negative 1/2. Negative root 3 over 2. Oh, that means I filled that one out wrong too. Dang. I should have filled all my quadrantal ones out first. But it's okay. 1/2 and negative root 3 over 2. Alright, so all the ones that are on the axes, the ones I don't have filled out or should have left blank, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay. So, filling out this chart again, sine is y, cosine is x, tangent is y over x. Cosecant is 1 over y, secant is 1 over x, cotangent is x over y. If you want to know what values are positive where in quadrant 1, all of them are going to be positive because it's x, y. Quadrant 2 is negative x, y. So the only positives are going to be sine and cosecant. Quadrant 3 is negative x, negative y. So tangent and cotangent are positive. Quadrant 4 is x, negative y. So the only ones that are positive are cosine and secant. And there we have it.